Hello and welcome to another video. In this video we're going to be working on string matching in an array. And in this one you're given a string of words and you want to return all strings and words that are a substring of another word. You can return the answer in any order. Substring is a contiguous sequence of characters within a string. So like in this first example, as is in mass, because here's an as. And then hero is in superhero, so those are the two. And then in this example, et is in LeetCode and code is in LeetCode. And then here, there's nothing. So there's kind of three ways of doing this, and I'm just going to talk about the basic one, given this is an easy problem. If you want to look into other ones, I can tell you, like you can use a try, or you can use a string hashing algorithm, but I think that's like massive overkill for a problem of this difficulty. So usually if it's like a hard problem, then I'll talk about those, but if it's like an easy problem, then I'll just usually come up with the most straightforward solution or optimal one, as long as it's like not super complex, and I think the other ones are reasonably difficult. So the straightforward solution essentially is we can basically just take every single word and we can just say like, so for example, let's just say we have some words like this. We can just say like, okay, let's just take our word and compare it to every single word, every other word in this array. And we don't want to compare it to itself. So like we're gonna skip that. So basically we're gonna compare this to every other word, and we're gonna compare this word to every other word, but we want to compare like every single location where it can be in the other words. So for example, if we compare this word to this word, we know right away that this word can't be in this word because this word is bigger. So if the word we're trying to find in another word is bigger, then we just skip. So like here, we're just gonna skip. But here, it's not bigger. So if this word is in this word, the only place it can be is starting at the beginning. So like at index 0. So let's just kind of show what I mean with an array. We'll make it easier. So let's just say we have this word. We won't even put in characters. And then we have another word that's this many characters. So essentially what we're going to do is we're going to say, let's just try to compare like this. Or let's say it's actually... Okay, there we go. So the top word is the word we're looking in, and the bottom is the word we're looking for. So, you know, let's say this word just happens to be like, whatever, super hero, whatever, superhero-y or something. Not a word, but who cares? And let's say we're looking for hero. So basically, the way we're going to compare is we're going to like say, does this equal each other? Just like a substring or whatever you're using in the language. If it does, then we're done. Then we're going to say, does this equal each other? If it does, then we're done. Does this equal each other? Does this equal each other? And so on and so on. So we're going to try to find a match this way, where we're going to try every single starting location in the word we're trying to look in. We're going to look for this word that we're looking for, essentially. And that's what we're going to do. So where can we look for? Well, we can look at every single starting location, but there have to be enough indices at the end to match the length of this thing. So because this thing is length 4, there have to be at least four things at the end. So we can't look, for example, here, because this is too short. So essentially, we're going to start at the start of the word, and we're going to look at every single location up to where there's enough left. So basically, we're going to look at like this sequence of 4 characters, this sequence of 4 characters, this sequence of 4 characters, and so on and so on. And then if the word we're looking for, if we find it in any other of these words, we're just going to have like a Boolean value saying like we found it, and then we'll just break everything and put it into the result. Because if we found ass in mass, let's say, we don't want to look for it in other places. We don't want to have duplicates. You could also use a set depending on the language. Like you could look in every single word and then you can just have duplicates. But in Go, I'm just gonna have like a variable there. So that's essentially what we're gonna do. We're gonna have a nested for loop. So every word, we're going to look at every other word. We're going to compare the lengths. And if the word we're looking inside is too small, we'll just skip it. To be honest, I don't think we even have to do that because we're just going to look for every single valid starting index. So if let's say we're looking in here, there won't be a valid starting index because the valid end index would have to be like the length of this guy. Sorry, the length of this guy minus the length of this guy minus 1 or something. So then it just wouldn't exist. So when we do our for loop, like we'll basically never go into it. So we don't even have to do that case. But essentially, whenever we do find a match, we'll just break out of there, say we found a match, and not look through any other word. So essentially, nested for loop plus for every single word, we're going to look through every character. So it'll be something like n squared times w or something, where w is the length of the word, something like that. Okay. Yeah, so something like that. Okay, so let's do that, and that's kind of like the basic solution that you're expected to come up with without using any like advanced data structures. So we'll just make our result slice here. Slice and go is basically just like a vector or like a dynamic array in Python or something, or list in Java, same thing. So we're gonna loop through every single word. So, and this is the word we're looking to find. Then we're gonna have a nested loop. But before we do that, we're going to make a variable that's just going to be like, have we found this word? So we're going to say it's false. Then we'll have the nested loop of the words we're looking in. So word 2, range words again. Okay, so if we already added this word in, then we're just going to break out of this loop because we're done. So if found, we're just going to break here. Okay. Now we're going to look in this word, and we're going to look in every single valid index. So we're going to say for k 0, k is less than or equal to the length of the word we're looking in, so word 2, minus the length of word 1. And this makes sense because, like, let's say this is one character and this is one character, then this has to be at index 0, so this would be 0. Or if this was 2 characters and this was one character, it would either have to be at index 0 or 1, and then you would get that, right? You'd get k equals 0, k is less than or equal to 1. So this makes sense. So this basically you can check every valid starting location. So if word 1 equals, and this is like slice or substring or whatever language we're using, so this is going to start at k, and then the length we need to check for is k plus length of the word. So if this is equal, that means we found our match, so we just append it to the result. And then we need to make sure we don't keep looking here, and we just need to be done. So we're going to mark this found variable as true. We're going to break out of this loop. We don't need to keep seeing if this word is in the second word anymore. And so basically we want to break out of this loop and break out of this loop. And the way we do that is just have another variable there. I think in Go there is some weird stuff, like you can have like a label like in assembly or something, but generally discouraged using stuff like that. So, and in most languages they don't have that. So this is just like a better way of doing it. Alternatively, you could have your result being a set and then just convert it to an array at the end as well. Either one's fine. Yeah, and then we just return. Let's see the problem. Okay, so we didn't use I. Oh yeah, so I forgot one more thing. So if the words we're comparing is the same index, we shouldn't look for that, right? We shouldn't look to see if a word is in itself. So if I equals j, we'll just skip that iteration and just go to the next one. Okay, I think this is like word 2. All right. And yeah, there's more complicated solutions that are like substantially more complicated than an easy problem. So once I do like a harder problem or something that involves those, then I'll talk about those. So essentially, worst case scenario here, for every word, we're going to look at every other word and basically every character of that other word. Like, let's say every single word was the same length. Then you're basically going to look through every character. And not only are they the same length, but like they're almost a match. So then what would happen here is basically for every word, you're going to look for this entire thing. So let's just say like the average characters in a word is like W, and then n is the number of words. So this would basically be like W times n squared. For every word, we're going to look through every other word, and we're going to look through every character of that word or something like that. So something like that. Space of 1 because we just have the result. Yeah. And this found is just nothing. So yeah, it's going to be all for this one. And yeah, let me know what you think about this format where kind of like for the easier problems, I'll give an easier solution. Unless obviously, if there's like an optimal solution here that's like really easy, that doesn't have like advanced algorithms, I'd go over that. But yeah, I think going over like tries or string hashing or any of that in an easy problem is just doesn't make sense to me. So yeah, thanks for watching, and I'll see you in the next one.